Welcome back. Today we'll be solving largest color value in the directed graph. So we're giving you a directed graph with n color nodes and m edges. The number will range from 0 to n minus 1. So you're given a string of colors where colors I is a lowercase English letter representing the color of I nodes. So basically we have 26 different color that we can have, which is range from A to Z because those are the only 26 lowercase English letter. And then we'll tell you there's edges, J, where A and J means there's a directed edge from A to B. So since we know this is a direct graph, this is one key notes to what algorithm you want to use. And then we'll tell you that a valid path is that from some nodes to the other one. And then we want to return the most frequently occurring color. And if there is a cycle, this is the important part, if there's a cycle, we want to return -1. So let's look at this. So this example is you have 0 to 2, 3, and 4. This is one valid path. And then you also have 0 to 1 is one valid path. You can also call 2 to 4 is a valid path, 3 to 4 is a valid path, right? Because you just need a valid path which one edge going to the other one. So here we can see the longest valid path is 0, 2, 3, 4, but it doesn't necessarily mean that they're the largest color value. What we're trying to find here is because 0, 2, and 4 are the same colors, so this will be 3. And the other example here is since there's a cycle, so we want to return -1. So the cycle part is easier. If we do some algorithm, different algorithm, then we can find what we can do with doing the cycle. So let's look at this. So if we do look at this, this means that the first index will be A, and then B, A, C, A. So as what I said, you can see, you can treat this as a valid path, this as a valid path, or even this as a valid path, right? And then the longest valid path doesn't necessarily contain like the largest number. So let's say if I have like 0 to 1 to 2 to 3 to 4 to 26 to 25, let's say, and then they're all from A, B, C up to Z. This might be longer than 0 to 1 to 2, which contains a right? This is a longer path because this is like length of 26. This is a length of 3, but there are 3 most frequently happen value. This will be outputting 3. This will be outputting 1, right? Because they all occur to A, B, C, D, E up to Z just one time. And there's one thing we need to know that the longest valid path doesn't necessarily produce the longest color. So that's one thing. And one other thing is we want to check for cycle. So actually there's a way to do it. It's using topological sort. So what does it mean by that is when you do a topological sort, you can count, you have it in degree to count which one to have in degree 0, which will be the starting point that you can cross out. Like you can cross out this one first, and then this will be from in degree 1 to be 0. Then you can cross out 1, you can cross out 2, and then so on and so on, right? But if you have a cycle, which you can use a thing called another variable called process. So to see how many nodes you process. So if you have a cycle, then you won't process all the n nodes. So this is something that you want to keep track of. If the process is not equals to n, means that there's a cycle, and then you can can return -1. And then what's a high level of this? So given that you have an in degree, we know that by using the topological sort, the standard version is that you have a queue, that you add in anything that have an in degree, node equals to 0, and then you update it. Like when I process this one, so I go to all the neighbors and then update their in degree. Whenever the in degree is 0, I add them to the queue, right? Add to the queue. And the other thing is want to keep track how many like the max value of the most frequent colors that occur, right? So that's a problem here. In this case, as I said, the longest path doesn't necessarily contain the max value of the largest color value. So for each of the neighbor, for each of the neighbor, you want to go through a color code. So here we can say like each of this can contain a color code, and then we just want to update the color code to be the max of the neighbor color code or like the other one. So let's say I have this to be red. Let's say this is red. This, for example, this is red. And then when I have blue coming in, so this is blue and blue, let's say 5 and 6. So blue and blue. So I will say this is 2 blue and then 2 red. So when I pass it here, I will have the encoding system about how many blue from the previous one, right? So we can see what's the longest path right here. All right, this sounds a little bit confusing, but maybe I should just code it out. I think I need to improve my writing and some explanation. But let's look at the code. So so first we can do topological sort and just start with finding how many nodes there are by taking the length of the colors. Then we can build an adjacency list. You can do default which is a list, and then you can do an in-degree graph, and then we can do a color count for each of the nodes. So what this is saying is that we will, for each of the count, it will contain 26 elements, which is the 26 different code from A to Z, and then just do it for all the nodes. Now we can process the edges. So for UV in edges, since this is a directed graph going from U to V, so we can say U adjacency list U append V, and then since we going into V, we can say there's an in degree V will be plus equals 1. Then for topological sort, as I said before, we need a queue. And then in Python, you can do deque. On LeetCode, they already default you import the collections and the deque. But if you in an interview, you can maybe saying like the stack thing, and you want to go through the in degree. So if in degree I, which is the node, is equals to 0, we can add them to the queue. As I said, if we want to know if we can process everything and there's no cycle, we can keep a user process and say process equals to 0 to start. And then we can use the max value to keep track of what is the max color value that we have. So we need to go through all the queue. While queue, we can pop from the left. And then since we pop from the left, we process will be 1 more. And then we want to get a color coding, right, into a 0 to 25 index. But the color that they give us is A to Z. So what we can do is we can get the color by taking the ASCII value of it. So if we do this colors at the index of node, we get what color it is, and then we get the ASCII index, and then the ASCII value, and then we can do it to minus the ASCII value of lower character A to get it into the range of 0 to 25. And then you have this color count, which we do initialize for each of the node, and there are 26 of them. So the first, there's a 2D array, so the first one to pass in is what a node is, and then we want to pass in the color. So we want to plus equals 1 of the color, means that we encounter 1 more color before or up to this one for a valid path. And then we want to update the max value to be the max of the previous max value you have seen and this one. So including yourself, the color that you just added. Is this larger than it before? So when you're done with all this thing, now we want to look into your neighbors, because that's where you want to step in next, right? So for neighbor in the adjacency node, so for all of this neighbor, you can go through all of the 26 um, color index, or you could call color code, or A to Z, whatever it is. And then you want to count the max of it. So if you go in the color count of neighbor, and for this different color index from 0 to 20, 25, you want to take the max, because you can encounter another value path from the other way. Let's say the one that I say before. Let's go back to the example. Let's say I have a lot, like a longer list from here before, that's all like blue coming down here. So you want to update that when you see this one. Actually, the larger value here, it's the blue, which is 5, right? So that's what we're trying to do here. So going back to the code, so we want to take the max of yourself. So if you are the largest one with that color, then of course you want to take that. Or you want to count from your previous one, right? From your previous node. Notice that we don't have the +1 right here, because we already update whatever our color is. So when we call the color, maybe if it is the color of ourselves, we already updated it. When you're done with this, you just want to decrease your in degree by 1. And if the in degree now is equals to 0, then you want to append it to the queue. So this is the whole algorithm of the topological sort. You're basically done with this, and the last step is just to return it. So you can return a max value if process equals to n, means that you have the same number of the value that you process. There's no cycle, or there's no more like you process. Else -1 means that there's a cycle. So this is just the code. Run it. I actually can see if I'm accepted. Okay, and then we'll submit this. All right, I hope this is helpful. So I'll leave this for a little bit, and yeah, this is how you're gonna do it. All right, thank you all for watching, and let me know if you have any questions or any feedback for what I can improve in the future.